Hello everyone, let's look at this trig equation here. This is another trig equation in the quadratic form. And if you have watched my the other video of a similar equation, then you can actually see that this one is more difficult than that one because that one has just the same type of trig function for the whole equation. But this time we are going to have a sine x and a cosine x. They're different trig equations. Yeah, so let's think about how to handle this one. And by the way, for the other one, I actually will include the link for the other one in the description so that you can, if you want to watch it, then you can just click on the link in the description. Okay, now let's get started for this problem. So for this one, we just need to think about how to turn all trig functions in the equation into the same type of trig function. So that means either we gotta convert the sine square x into the cosine, or we can convert the cosine into the sine. And which one is easier? It's actually easier to convert the sine square x into the cosine x because there was a identity that will allow us to do it. And that one is called a Pythagorean identity. And so let's just write it down for now. So let's recall that if we have sine square x plus cosine square x, and that's actually equal to 1. And if we want to replace this sine square x, then we can actually just solve for sine square x right here. And so we subtract the cosine square x from both sides of the equation. We are getting 1 minus cosine square x. Okay, so that means we can replace this sine square x by this 1 minus cosine square x. So let's do that. Let's go to our equation. We have the 2, and then now parentheses. We are going to replace that by 1 minus cosine square x plus the 7 cosine x plus the 2. We are not going to do anything to the other terms. So now we have this equation. Okay, so the next step is to distribute the 2 to the 1 and then the negative cosine square x so that we don't have parentheses anymore. And after that, we can also combine like terms, right? So we distribute this 2 to the 1 and then also distribute the 2 to the negative cosine square x. So let's do that. We are going to get 2 minus 2 cosine square x plus the 7 cosine x and then plus the 2. And that's equal to 0. Okay, so that's nice. And as you can see here, we can actually combine the two constant terms. So we are going to get negative 2 cosine square x plus 7 cosine x, and then plus 4, and that's equal to 0. Okay, so that's good. Now, the next step is that we just treat it as a regular quadratic equation that we are solving. So if it's factorable, then we try to factor this left-hand side. If it's not, then we gotta use the quadratic formula. So first thing, we noticed that there was a negative number in front of the leading term here, and so that makes it hard for us to factor. So what we want to do is to turn this number into a positive number by multiplying the whole equation by -1. And to do that, then all the other signs, all the signs for the other terms will change. And so if we multiply everything by -1, then we are going to get +2 here. So we get +2 cosine square x. And then now the sign change, right? So the +7 becomes -7 cosine x. And then the +4 becomes -4. And that's equal to 0. Okay, so now it's easier to factor when the leading coefficient is positive. At this point, I'm going to just make a substitution. I'm going to just treat that cosine x as a single variable. So I'm going to just give it a name. Let's call it y, right? Okay, so we call the cosine x as y. Then in this case, we have a new equation, which is 2y and then square, right? Don't forget the square on this thing. I'm just saying that the cosine x is y. The square is not included in there, so we still have the square applied to this y. And then minus the 7, and then you have the y there. And then you have the -4. And that's equal to 0. Okay, so next step is to factor this equation now. That equation is actually quite easy to factor. So let's just write down the two factors. First, if we look at our leading term, we have 2y squared, and the only combination that we can have is that we have a 2y right there. And then the other one is just the y. Yeah, the other one is just the y. 2y times y is 2y squared. Now, what about the 4? For the 4, because we want a -7, so to get the 4 to get the -7, we actually want 8 and 1. So that means we are going to put the 4 here, so that when we multiply the 2 and the 4, we are going to get 8, and then we are going to get the 1 here. So I'm going to put the 4 right here, and then I will put the 1 here. Now, what about the signs? We want -7y. So that means we want -8y. So we should have y minus 4, and then 2y plus 1. Okay, so that's that. And then that's our factorization. Now let's go to, let's continue with solving this equation here. So I'm going to get 2y plus 1 is equal to 0. Or we have what? Y minus 4. And that's equal to 0. So now just solving the equation, we are going to have 2y minus 1. I mean, 2y is equal to -1. And yeah, so let's continue to solve this equation. 2y is equal to -1. And the other one is just y equals 4. Yeah, because we are adding 4 to both sides of the equation. Now, let's put a vertical line just to separate the work so that they don't get into each other's way. Okay, let's continue with the calculation. At this point, we can also just isolate the y, which will give us y equals -1/2. Okay, so once we solve for y, we can replace the y with our original function, which is the cosine x. And so to do that, then we will turn our regular equation back to a trig equation. So it becomes cosine x, and it's equal to -1/2. And the other one is the cosine x, and it's equal to 4. Okay, so regarding this case on the right hand side here, because the range for the cosine is -1 to 1, so that means we cannot really have any value that we plug into the cosine that and it's equal to 4, so that's not possible. That means there is no solution for this equation here, right? So we are just going to say no solution for this equation on this side, right? There is no solution for just this particular equation. But then we may still get a solution from the other case, right? So now let's look at this cosine equals -1/2. For the cosine x equals -1/2, just like usual, we are going to just draw the right triangle and then use the reference angle approach. Okay, so drawing the triangle is actually quite simple, and then we can just label the angle, and then that's a right triangle. Now, cosine is what? Cosine is the adjacent over the hypotenuse. And so again, this is actually a 30, 60, and 90-degree right triangle. And the angle that's facing the side with length square root of 3, that's an angle of 60. So that's really just saying that our reference angle, it's going to be pi/3. And then now we need to take care of the quadrants. For the quadrants, it tells you that cosine is negative, right? So when is cosine negative? Which quadrant? It's actually quadrant 2. and also quadrant 3. Yeah, so once you have this piece of information, then you would be ready to write down the answer. Um, what we want is that we want an angle that's in quadrant 2 and it has a reference angle of pi over 3. And so that's 120, right? So that's would be 2 pi over 3. And yeah, so that's that's an angle in it's 120 degree. What about the other angle? The other angle is in quadrant 3, and that has a reference angle of 60, so that's 4 pi over 3. Okay, so that's actually the angle of 240. Okay, so those are the two solutions, and they both come from this case 1. And then what about the case 2? The case 2 does not use any solution. So our only solutions on this interval from 0 to 2 pi is 2 pi over 3 and 4 pi over 3. Okay, so that's it for this problem. The idea, again, just to talk about the idea for solving this type of quadratic trig equations, is that if you are not getting the same type of function, we can use the Pythagorean identity to turn one of the functions into the other one, so that now the whole equation is just in terms of cosine or sometimes sine. Okay, so that's it. If you like this video, please subscribe to my channel and then give me some support. And I really appreciate that you're watching this video until the end. Thank you, and I will see you next time.